Hi there. So once again, I'm doing another one-handed video. This is going to be a little shaky because I'm not using the tripod. We want to talk about simultaneous solutions for systems of equations. That's a fancy way of saying when I've got two things graphed, what are the intersections that work in both of them. They're called simultaneous solutions because this point here, which is 2, 3, actually works in both these equations here. Because if I plug in a 2, 2 times 2 minus 1 is 3. If I plug in a 2 there, 2 times 1/2 is 1 plus 2 is 3. So 2, 3 is the solution to this simultaneous. It is the simultaneous solutions, simultaneous meaning at the same time, that works in both of them. And that's an Algebra 1 thing, and there's lots of ways for solving that, including there are algebraic ways to solve this both by substitution and elimination. And there are tons of links out there on Khan Academy and such if you want to go back and review that. We are doing this. So we've got two equations here, one of which looks like probably a third order degree equation because it's got 3 single roots, and something else that probably is a fourth degree equation because it's even, because it's both end behaviors pointing up. Looks like it's got 2 double roots. Maybe those coincide, maybe they don't, but I've actually got 1, 2, 3 places where these intersect, so those are all potentially solutions. So the question is, well, how can I find these out? And we're not going to try to solve it algebraically. We're simply going to use the calculator to try to figure these out, and then we may do some old-fashioned by-hand checking just to make sure we typed in things right. So I came up with some equations, and most of the examples I've done in class look like this. Actually, don't look like this. They're typically in general form. I got 2 in factored form here. The first one being x minus 2, x minus 3, and x plus 2. And the second one, just a second order equation, negative x minus 3 times x plus 1. So when I graph this, hit graph, first graph was already there, and there's the other one. Kind of off the screen. Ideally, we'd like to see all the features. So I'm going to change my window setting and just make my min a little smaller and my max a little bigger. And maybe we'll go by 5s, except I screwed that up. Make that 20. And I think this will all fit now, so I'm going to hit graph. And now I've got something that fits kind of nice. And I can see roughly where these things intersect. I've made this second line a little bit bigger. Looks like it intersects in 3 places here. And so to find these, one of which you should already know from the vertex form, by the way. If we go back and look at this, you should be able to recognize what one of the intersections are just by looking at our vertex form there. But back when I go to graph it, if I want to find it out here, so here's the trick. In the same way that you probably know how to do minimum and maximum, if we do second and calc, we can do, second and calc. What did I do? Oh no, thing I've never been in before. Let's do a quit. Okay, we're going to graph it. Okay, try it again. Second, calc. And I'm going to do 5 for intersect. And then if you've only got 2 curves graphed, this is pretty easy. And by curve, they mean equations. It'll automatically default to the first curve. There it is right there. So I'm just going to hit enter. And then it will automatically jump to the second curve. And I'll just hit enter. And the only reason I wouldn't need to hit enter here is if I had 3 equations here, then I might need to use the up-down buttons to jump between them. In general, just do 2. It makes it super easy. So I hit enter. And then there's actually 3 possible intersections here. So I need to get close to one that I want to solve. So I'm going to get this one on the left here first. So I'm roughly about right there. I hit enter. And it will think, and then tell me the intersection is negative 2.3 roughly and negative 6.91 roughly. So that's one of my intersections. And then I can do that again, second calc, and 5 for intersect, and once again, enter, enter, but this time I'm going to move it over a little bit and try to get that one in the middle. And so we'll think, 1.30 and 2. Well, I guess it's 3.91. I'm going to just go to 2 decimal places here for 1/10 for the example I'm about to do. And this last one, you should actually know what it is already because of the zeros. So if I do second and calc, and 5, and enter, enter, and then I'm going to go over to this far one here, say enter, and it will tell you that it is 3, 0, which we should have known already because of the factored form of the equations. Okay, I'm really almost done. This is the way we're largely going to do these. For students in my class, make sure everything fits in the window and that you can draw all the max and mins and then read the directions and see if you actually need to write down the scale and or label any of the intersection or max min points. Generally we won't, we'll just do the sketch, but read the directions. Alright, so the last thing we might want to do is we might actually want to check. And there's a couple of reasons we might want to check. First of all, you should probably double check and make sure that you've typed the equation in correctly. I'm pretty sure this was the equation, but if it was written this way, especially if it had some squares or third powers in it, it's really easy to type it in wrong with the calculator. So it's worth double checking. Sometimes it's a pain to check all the points, but at least check one of the points. Based on this equation, 3, 0 seems kind of silly to check because I can just look at it and say that's going to be 0. Yeah, it's going to make everything 0, so that's definitely going to work in that equation. But let's see what happens if I want to check 1.3 and 3.9. So I'm just going to plug those back into my equation, and this is oftentimes the way you will see a check. You will see it as the y value equals, and the x value is plugged in, and with a little question mark over it. And that's saying I am checking, I'm not sure if those are equal, I'm trying to check if those are equal. And then so I'm, in this particular case, I calculate those. If this was written in general form, I might have an x to the third, where I'd have to take 1.3 x to the third, and then maybe 1.3 x squared, something like that. But in this case, it's in factored form. When I plug these in, these are the 3 values I get. I'll probably do a little mental math and not enter the negatives in the calculator. Just know it's going to be a positive answer. And when I multiply that all out, I get 3.927. If you are not using exact values or rational values, you're not using fractions, you will often, when you get these checks, will not get exactly the same number, but you should get something super close. So that just checks it in one equation. It could certainly be right in one equation and wrong in the other. So I need to check it in the other equation. So the other equation was this. We had y equals negative x minus 3 and x times x plus 1. So I plug that in, and I simplify that a little bit. And so ultimately that also comes out to about 3.9. So that seems like it checks. That is pretty much it. Double check your equations when you put them in the calculator. Second calc intersect to find those values. And then if you're going to draw the graph, make sure you're reading the directions, but certainly get all the key values such as the max and mins into the window. That's all. Ciao.